Now let's learn a new concept called software development lifecycle, or sometimes we call it as SDLC. Basically, these are the same steps which we have already covered, but now we are going to learn more deeper insights about these topics, and then we will cover different models available which is applicable for software development lifecycle. Okay, so the process of creating software typically follows a structured methodology known as the software development lifecycle. Starting, for example, we have done the requirement gathering, analysis, then we did system design, then the implementation, then quality assurance, deployments, etc. Right? So there is a way of those steps to be executed, and those comes under SDLC. SDLC includes phases like we covered earlier: requirement analysis, system design, implementation, testing, deployment, and maintenance. And we have already learned about them. Now there are various models available for SDLC. What I have done, because there are various, I have categorized them into three parts. Let's see one by one which model is applicable for which use case. What are the features of these models are having, which is better than other, right? So software development lifecycle models are frameworks that outline the various stages involved, and we know the stages: the requirement gathering, testing, development, implementation. All those are stages. So SDLC models are frameworks that outline the various stages involved in software development. Each model provides a structured approach to planning, creating, testing, deploying, maintenance, etc. everything of the software. And there are various models available: Agile, Scrum, Waterfall model, which is a very legacy one, DevOps model, Kanban, Spiral. So there are lots of models available, right? So we will learn about those models in the upcoming slides, right? So like I said, I have categorized all those models into three categories: traditional models, and agile models, and modern and hybrid models. Traditional models are the legacy ones which are used since the inception of software engineering. Agile models are still popular, right? And then modern and hybrid models, which are like a combination or a combined flavor of traditional as well as agile. Sometimes what we do a tailored model, which is a combination of multiple models as per business requirement. So first one is traditional models, and we are going to cover three models. One is the waterfall model, V model, and incremental model. Let's first understand waterfall model. Waterfall model is a traditional software development methodology that follows a linear and sequential approach. It is one of the easiest model used in software engineering, and it is structured into distinct phases where each phase must be completed before the next one begins. Right? That's why it's linear. So one is dependent on the previous one. Until first is complete, we cannot move on to the second one. That is why it is called a waterfall or linear or sequential model. So this diagram depicts why it is called waterfall, because we have already gone through the various stages of the software development lifecycle: requirement gathering, system design, implementation, quality assurance, deployment, and finally maintenance. And these are different phases, right? Once the requirement and gathering is complete, then we will move on to the next phase, system design. Once this system design is complete, we will move on to the next phase, that is implementation, then testing, then deployment, and then maintenance. We cannot move to the system design until the requirement gathering is complete. We cannot move on to implementation phase until the system design is complete. We can move into the testing, deployment, and maintenance phase until the previous phase is complete. And that's why it is called waterfall, because just imagine it as a waterfall. The water is flowing from upside to the upside, right? So until it will complete this step, it won't reach to this step. That's why it is tricky in a way, because sometimes we understand, for example, while system design, we understand, okay, there is one requirement which is not yet clear. We should go back to the previous phase and confirm, have some more brainstorming sessions with client, customers, stakeholders to gather more understanding. But since waterfall system doesn't allow that, right? So it's like a breach where when we want to discuss some more understanding, we want to take some more understanding for the requirement. So that is one of the disadvantage of using waterfall model, that since it's sequential, we cannot go back to previous state, previous phase, and do some refinement. Let's see the key phases of the waterfall model. Like we have covered earlier, requirement gathering, understanding and documenting what the software needs to achieve. Stakeholders provide input to define project goals and requirements. We do brainstorming session, we do interviews, etc., documentation, etc. We see the existing architecture, we see the existing documentation, right? We gather whatever requirements we can get from the client or different stakeholders, and we document them. The very critical phase, like I said earlier. Then the system design phase. This is translating the requirement which we have received earlier into a blueprint for the software. Detailing architecture, we create diagrams, we create documentation, again basically converting those layman language, the non-technical language, to the technical specific documentation, etc. We create user interfaces and system interaction diagrams. There are multiple type of diagrams we have, so we create those diagrams, whether it's system context diagram, logical flow architecture, etc., etc. So we create those diagrams and documentation those come in the system design. Then we have the implementation phase. The system design goes to implementation team as input, and they do the actual coding of the software based on the design specification. Developers write the necessary code to build the software. Then it goes to quality assurance team. The testing happens, systematic verification and validation of the software to ensure it meets the specified requirements. This phase involves identifying and fixing bugs, right? Then after the testing is complete, then it will go for deployment. So like we learned earlier, there are multiple deployment environments, whether it's development environment, quality assurance or QA environment, staging environment, or pre-production environment, or finally the production environment, right? So releasing the completed software to users and integrating it into the operational environment, that is called deployment. Then comes the maintenance phase, where ongoing support and updates to the software post deployment, some more features, additional features, some enhancements, or maybe some bugs which are being reported after this is live on production. So that those activities go to maintenance phase, and this includes fixing any issues that arise and making enhancements based on user feedback. Now let's understand the advantages of the waterfall model. So one is simplicity. It is easy to understand and manage due to its linear structure, right? Clear documentation. Each phase produces documentation providing a clear project record. Defined milestones. Progress is easily tracked with clear deliverables at each stage. So it's easily understandable why it is, what is the advantage of this model, because it is easy to understand. So it is sometimes not easy to manage, or the execution is not that much fruitful, but yeah, it is easy to understand. And let's see the disadvantages of the waterfall model. So first one is inflexibility. It is difficult to accommodate changes once a phase is completed. If requirement changes, it can be costly and time consuming to revisit earlier stages, right? So for example, if there is any requirement changing, then we again need to start from the very first phase. Again, we need to follow all those steps, the requirement gathering, the system design, the implementation, right? And of course, in linear fashion only. Lead testing. Bugs may go undetected until the testing phase, leading to potential issues being discovered late in the process, because the testing will be done post the implementation is fully complete. So if there are any bugs, I mean, we are not validating small chunks of the functionality. For example, we have been given this 100% of some work. We will not validate this like the 10% of work is tested, validated, it's working fine, then another test. No, it's like you complete the 100% of work and then validate it. So it is kind of late testing and late discovery of the defects or bugs. And assumes requirements are clear. works best when requirements are well understood upfront, which is not always the case. 99% or even 100% is the case. The requirements are never crystal clear. They change frequently. So that's why the waterfall model usually doesn't work, right? Because the requirement changes, and if the requirement or changes are changing, then the phase, this linear approach will fail. Okay, let's see the conclusion. So waterfall model is suitable for projects with well-defined requirements and where changes are minimal. However, its rigidity can be a limitation in more dynamic and iterative environments where methodologies like Agile may be preferred. Right? So if the project is well-defined, it's a small project, minimal changes are required, then we can consider waterfall model. But if it is a big project, more iterations are required, there are multiple requirements we need to execute, right? Multiple functionalities, it is a big enterprise solution, then we should think of some other model. Maybe Agile is one of them, right? Waterfall model may not be suitable for that type of project or requirement. So within the traditional model, after waterfall model, let's cover the V model, or we also call it as validation and verification model. The V model, also known as the validation and verification model, is a software development process that emphasizes the relationship between development stages and testing activities. It is an extension of the waterfall model where each development phase has a corresponding testing phase, visually represented in a V shape. So this is the key here, each development phase has a corresponding testing phase. Now we have seen that waterfall model has one disadvantage, that 100% development is complete, then only the testing will start, right? So let's see how V model will help here. Let's see the key features of the V model. Verification and validation. The model distinguishes between verification, building the product right, and validation, building the right product, ensuring that each aspect of the software is checked and confirmed. Early testing. Testing activities are planned alongside development, allowing for early detection of defects and ensuring that each phase meets its requirement before moving to the next. Clear structure. The model provides a structured approach with clear defined phases, making it easier to manage and track progress. Now let's understand with this pictorial format. So what it says, and that's why it's called V model, because if we see, for every phase of the development there is corresponding a testing phase. So for example, requirement design, we have the acceptance test. For system design, we have the system test. For architecture design, we have integration test, and so on, right? So that's why, because it looks like, we can imagine it as a V, that's why it is called V model. Let's see the phases of V model. So likewise, we have waterfall model. It is just extended version of waterfall model. We have the same phases. Likewise, we have the requirement analysis, system design, architecture design, the module design, etc. I mean, whatever we have covered, it gives some extra stress on the validation, on the testing phase. So for each development phase, there is a corresponding testing phase. So requirement analysis, it defines user needs and system requirements, right? And the validation would be to ensure requirements are complete and clear. System design will outline the high level architecture of the system, and validation will check design alignment with the requirements. Architectural design details the system's structure and component interaction, and in the verification, it will confirm that the architecture can support requirements. Then the module design will break down the architecture into individual components, and then the verification phase will ensure that the designs for each modules are correct and feasible. Then goes to implementation phase, actual development of the code, and then the validation phase will start from here, right? It involves unit testing, implementation phase, corresponding unit testing for individual modules. Then we have integration testing. So test interaction between integrated modules. If there are multiple systems we are integrating with, so validation of those integrations, if they are working together or not. Then we have system testing. It validates the complete system against requirements, and validation will check if the system meets user needs and business objectives. Then we have the acceptance testing, final validation by business users and users before deployment, and the validation phase will confirm that the user is ready, the system is ready for production or not. Now let's understand when to use the V model, when should we use, which use cases are appropriate for V model. Okay, well-defined requirements. The V model works best when the project has clear, stable and well-documented requirements from the outset. So if requirements are likely to change frequently, a more flexible model like Agile may be preferable. Right? So if the requirements are fixed, very well defined, then V model can be considered. Regulatory and compliance projects. Projects that must adhere to strict regulatory standards. For example, healthcare industry, finance industry, aviation industry, right? Because there we need that every phase has done the correct job. We need revalidation of each phase, right? So that is a good example where we should use it. And it benefits from the V model structured approach to validation and verification. The documentation and traceability aspects are crucial in these scenarios. I mean, the healthcare industry, finance industry, or aviation industry, or legal, something related to legal. Smaller to medium-sized projects. The V model is often most effective for smaller to medium-sized projects, where the complexity and scope are manageable. In larger projects, a more iterative approach might be required to handle evolving requirements. Consider we have a small project, so it is easy to even foresee what will be the requirement. The requirements can be freezed, requirements can be understood, well understood, right? But if we are building the solution for enterprise, where it's a huge enterprise, the solution is huge, there are lots of requirements, it is very difficult to have well documented requirements in the start of the project. Next would be stable technology and environment. If the technology is tech and project environments are stable, the V model can be very effective. In rapidly changing environments, more adaptive methodologies may be necessary, again Agile. Projects with well-defined testing strategies. The V model is ideal when there is a clear strategy for testing at every phase of development. Teams should be prepared to develop comprehensive test plans and have the resources to execute them. And the last one would be clear project timelines and milestones. The V model is suitable for projects with defined timelines and milestones where deliverables are clearly outlined. This model helps keep the project on track by emphasizing the completion of each phase before moving on. So these are the use cases where we can consider V model as the SDLC model. Now let's see the advantages of V model. First one is clarity and structure. The model's structured approach allows for easy tracking of progress and understanding of relationship between development and testing. Early defect detection, like I said, because for every development phase we have a corresponding testing phase, so early defect detection will help. Testing is integrated into each development phase, enabling early identification and resolution of defects. Improved quality, of course, because for each phase we will have corresponding testing phase, so the quality will eventually improve. With the rigorous validation and verification processes, the model enhances the overall quality of the software. Let's understand the disadvantages of V model now. So first one is it's rigid in nature. Likewise, in waterfall model we cannot go back. The first phase is complete, then only we will move forward. In this phase also, the development phases are having corresponding testing phase, but we cannot go back to fix anything, right? The V model is less flexible than agile methodologies, making it difficult to accommodate changes once development begins. Assumes requirement stability. The model assumes that requirements are well defined and stable from the outset, which may not always be the case. 99% case requirement changes. So it is very difficult to have static fixed requirements and then on top of that we start working. So that's why this is one of the disadvantage of this model. High upfront planning. Significant time and effort are required for planning and design phases, which may delay the start of actual development. So let's conclude in this. The view model is an effective approach for projects where requirements are clear and stable. This is the key term. So if requirements are clear, not changeable, not changing, it's stable, then it can be considered. Its emphasis on validation and verification at each stage ensures high quality software, making it suitable for safety critical systems where thorough testing is essential. And the examples I had given is life science related project, healthcare related project, aviation related projects, right? So we are discussing traditional models, SDLC models, and this one is the incremental model. The incremental model is a software development approach that builds the system in small, manageable segments or increments. Each increment represents a functional piece of the software, allowing for gradual enhancement of the product through multiple iterations. So we got a big requirement where we have, for example, multiple features to be included in a digital platform. What we will do, we will first prioritize those requirements, and maybe we will have like this whole project will go in 3 phases. Phase 1 will have the most prioritized item, phase 2 will have the lesser one, phase 3 will have the least priority items, and then this go live, the deployment will happen in incremental fashion. Means first will go the highest priority items will go in the first release and so on, right? So that is called incremental model. And each increment, each release will be a full functional capability. It's not like that we are delivering something and it's not functioning properly. So it will be a fully functional module which we are delivering. Let's see the key features of incremental model. So first one is for sure, because we are seeing incremental model, so we will have phased development, phased delivery. The software is developed and delivered in increments, iteration 1, iteration 2, iteration 3 and so on, with each increment adding new features or improvements based on user feedback. Early delivery. Initial increments can be delivered to users early, providing value and allowing for real world testing and feedback. Flexibility. The model allows for changes and adjustments based on user feedback and evolving requirements, making it adaptable to changing needs. Let's see an example. See, so for example, we have received one website which has both static pages and dynamic pages, right? We started development of this website, and as per incremental model, what we had been aligned with the business, that first we will release the static pages, and once in the second phase we will deliver the dynamic pages, dynamic functionality. For example, registration is there, login feature is there, any dynamic feature is there where we are integrating with downstream systems, etc., right? So static website, to make a static website, it is easy to develop because all we are playing with the text, images, etc., correct? Now since we are delivering this static website in phase 1 as soon as early as possible, we will have good impression, we will in front of client, in front of customer, because it will add value to the client, and also that in the next phase client is going to receive the second dynamic functionality, right? And both these phases, iteration 1 and iteration 2, in which we are delivering static website and then the dynamic functionalities, they both are separate, they both are individual and working modules. Those are not dependent on each other, that unless the dynamic functionalities are complete, we cannot access the static pages. Now let's see the phases of the incremental model. And since we have already discussed the SDLC, these phases will come again and again, because all these models have modified these phases only, right, in a way or in a way or other. So first one is requirement gathering. We'll get the initial requirements, collect them, prioritize them, because now we are talking about the phased delivery. So we need to collect not only the functional requirements, but also to understand which functionalities are having more priority than others, so that those can be planned in first iteration, and so on. Not all requirements need to be defined at once. Only those for the first increment are necessary, because anyway eventually we are going to get feedback also from the client after first iteration, and those can be combined with the second iteration or third iteration. Design and development. The system is designed and developed incrementally. Each increment includes a specific set of functionalities, right? Testing phase. Each increment is tested for functionality, usability, and performance, ensuring that new features integrate seamlessly with existing ones. Deployment. The increment is delivered to users for feedback, and the product can be further refined based on their input. And repeat. This process will repeat. The process is repeated for subsequent increments with ongoing requirements gathering, design, development, testing, any user feedback, whether it's an enhancement, bug fix, etc. Right? So these whole phases will repeat. Again, requirement gathering, design, development, testing, deployment, again repeat. So it's like that. That's why it's called iterative deployment, iterative model. So let's see the advantage of this incremental model. Early realization of value. Users can interact with early versions of the software, providing feedback that can be incorporated into future increments. Reduced risk. Issues can be identified and addressed in early increments, reducing the risk of major failure later in development. So something that we have built the whole product at once, and now it is now the client see this and they go, oh no, this is not we are even looking for. So the whole time, investment, money, etc., right, everything is just went in vain, right? So it is reducing risk, because first we are because it's incremental delivery, so first we are phasing out the major requirements, and then we are delivering it, getting the feedback. So again the risk is reduced. Flexibility. The model allows for adjustments to requirements and design as the project progresses, accommodating changing business needs. So it's flexible in nature, of course. Improved quality. Continuous testing and feedback lead to higher quality software, as defects can be identified and fixed incrementally. Okay, let's see the disadvantages of the incremental model. Of course, it is better than the previous ones, but let's see what are the disadvantages. It requires good planning, and to be true this point, any project, whether we are using any of the model, SDLC model, it always requires good planning. Effective management and planning are essential to ensure each increment aligns with the overall project goal. Integration challenges. As more increments are added, integrating them into a cohesive whole can become complex, and I'm going to discuss about what is this cohesive coupling, etc., and how can we cope up with all these while we will do this architectural design. We have so many architecture styles and design patterns. We'll see which one we should use, so that at least we can remove this type of challenges. One of them is integration challenge. Potential for scope creep. Flexibility in requirements may lead to additional features being requested, potentially impacting timelines and budgets. So let's conclude the incremental model. The incremental model is particularly effective for projects where requirements are expected to evolve. So that is actually the case for 99% of projects. The requirements are always evolving, or where user feedback is crucial. So that is also like for almost all projects. So it means this incremental model is applicable for almost 99% of projects. By allowing for gradual development and continuous improvement, this model helps ensure that the final product is well aligned with user needs and expectations. So overall, this model is better than the previous two ones, which is the waterfall model and the V model, because it gives more flexibility. Of course, V model is one of the model which is crucial for few of the applications that I discussed earlier. For example, aviation industry, healthcare industry, etc. Right? But all these models have significance for particular use case, for particular business requirement, and then we decide which model is best for this use case. Now, after traditional models, we covered 3 traditional models. Now we are going to learn agile models. So let's cover, we have agile model, DevOps model, and RAD model or RAD model. First one is the agile model. So okay, this term agile. Agile model is an iterative and incremental approach to software development that emphasizes flexibility, collaboration, and customer feedback. Unlike traditional methodologies like the waterfall model, Agile promotes adaptive planning and encourages rapid delivery of small functional software increments. So small. So there is a big requirement. First we will create small chunks of those requirements and we will have incremental delivery. So that is what we are going to do in the agile model. Let's see the key principles of agile model. First one is iterative development. Software is developed in small manageable units called iterations or sprints, typically lasting from 1 to 4 weeks. And ideally, in ideal scenario, sprint is usually of 1 or 2 weeks, preferably. If it is 4 weeks sprint, then it might not give you that agile flavor. Each iteration results in a potentially shippable product increment. And this is actually a term in the agile that is called PSP, potentially shippable product. PSP, it means whatever we are developing, it's a very small product, but shippable means it can be live, it can go to production, and it works as a standalone unit, right? Customer collaboration, frequent communication with stakeholders and users is prioritized to ensure that the product meets their needs. Feedback is gathered regularly to guide future development. It's flexible in nature. Agile embraces changes, allowing team to adapt to evolving requirements even late in the development process. Right. So, for example, this sprint is of 1 week, right? And I got a new requirement in the next sprint, which is going to start the next week, right? We can put in those requirements, whether those are enhancements or some bugs, right? So flexible in nature. Self-organizing teams. Agile promotes empowered teams that can organize their work and make decisions collectively, fostering creative and ownership. Right? So small teams and agile teams. So each team will have, for example, one backend developer, front-end developer, BA, right? They collectively get the work. They collectively work on those. We have regular stand-ups, etc. And then finally they make the collective decision. So that is like the more increased collaboration among the team members, right? Continuous improvement. Teams regularly reflect on their processes and outcomes, seeking ways to enhance their performances and product quality. Let's see the common agile frameworks. We have these are the popular ones: Scrum, Kanban, and XP. Right? Scrum and these are popular. At least Scrum and Kanban, they both are very popular. A popular framework that divides work into sprints. So and sometimes we use these terms if you work for a project: Scrum ceremonies, daily stand-up, retrospective, etc. Right? Into sprints with the defined roles. So we will have Scrum Master, Product Owner, development team, etc. Right? Scrum Master, who will be responsible for running the show, will work as a facilitator, getting the requirement, providing this information to the development team, etc. Product owner, who is going to own that product, the whole digital platform, right, from where the requirements are coming, will decide which requirement will should be taken first, and so on. And finally the development team, right, the front end developer, the back end developer, the integration developer, etc. And ceremonies like daily stand up and sprint reviews, etc. Right? The next type is Kanban, and it focuses on visualizing the workflow and limiting work in progress, enabling teams to manage tasks more efficiently. And then we have extreme programming, XP. It emphasizes technical practices like pair programming, test-driven development, and continuous integration to improve software quality. Now let's go into detail of each one. Scrum. Scrum is an agile framework used for managing and completing complex projects. Primarily in software development, it provides a structured yet flexible approach to project management and emphasizes collaboration, iterative progress, and customer feedback. And mostly I see in all of the projects, usually we use Scrum only because of course it's the benefits of the iterative behavior. We get the requirement and then phased delivery. Sprint is of 1 or 2 weeks, right? So it is easy to adapt new requirement if there are changes coming. So we can have show and tell sessions with the client to understand the feedback of the client, etc. Right? Now let's see the key components of Scrum. So first one is roles of the team members. We have Scrum Master, Product Owner, and Development Team. These are the main roles. A Scrum Master facilitates the Scrum processes, removes obstacles, and ensures that the team adheres to Scrum practices. So for example, if development team they get any blocker because the requirement is not clear, or there is an external dependency, maybe the external vendor is not providing the API response, etc. So what development team will do? They will reach out to Scrum Master, will tell him or her that this is the dependency we have. Now it's his responsibility to get those things resolved, right? Product owner represents stakeholders and customers, responsible for defining and prioritizing the product backlog to maximize value. So he's like the boss of that product. He is going to provide all the feedback, which requirement should go first. He will decide. He will attend the show and tell sessions. Will provide his evaluation, provide the feedback, etc. And then we have the development team, cross-functional, right? Whenever we talk about this term Agile or Scrum, you will hear this term cross-functional. Cross-functional means front-end developer also knows the back-end development, vice versa. People know stuff. They are not much dependent. Even the full stack development stuff, these key terms came from here itself, right? The cross-functional means within the team we will have people who are cross-trained, means they know they have all the skills which is required for that project, right? So for example, we need a tester, we need developer, we need front-end developer, back-end developer, BA. So these all people are there in that team. That is a cross-functional group of professionals who work together to deliver the product increment. So, and there can be multiple teams. So one team, another team, and third team. Now all these groups, these teams would have all those type of those roles. I mean, so for example, front-end developer, back-end developer, PA, tester, again front-end developer, back-end developer, PA, tester, right? So this type of team formation will happen as part of Scrum. Then we have artifacts. Artifacts will be product backlog, sprint backlog, and increment. Product backlog is a prioritized list of features, enhancements, and bug fixes that need to be addressed in the project. That is product backlog, a prioritized list of features and enhancements. Sprint backlog, a subset of items from the product backlog. So product backlog is a bigger chunk of items, right? Now consider few items which should go as part of sprint, because the sprint is of 1 or 2 or up to 4 weeks, right? So that subset from product backlog is sprint backlog, a subset of items from the product backlog that the team commits to completing in a specific sprint, that is sprint backlog. And increment is the sum of all completed product backlog items at the end of sprint, representing a usable version of the product, that is called increment. Now let's understand the various events within Scrum. So first one is sprint. Sprint is a time boxed iteration. Like I said, starting from 1 week to 4 week sprint we can have. A time boxed iteration typically lasting from 1 to 4 weeks, during which the development team works to complete the sprint backlog. And sprint planning, a meeting at the start of each sprint where the team decides what to accomplish. So for example, now from this sprint is going to start. Before this sprint will start, we need some work, right? Now that work will be decided in the sprint plan. Daily scrum, a short daily meeting, usually up to 15 minutes, right, for the team to discuss progress and any obstacles. So in the scrum, right, daily we have calls, that is called a daily scrum, where the development team, all the team members, they join the call for 15 minutes. They just update that what they have done yesterday, what they are planning for today, is there any blocker, and typically it should end within 15 minutes. And if there is any obstacle, they will inform Scrum Master, and it's Scrum Master's responsibility to get those issues or obstacles resolved. Then we have sprint review, a meeting held at the end of a sprint to demonstrate the increment and gather feedback from stakeholders, right? Sometimes we do show and tell session also with customer, with stakeholders, to after the development is complete, before we make it live, we just have arrange a meeting in which we show them that okay, this is what we have developed, please confirm if this is what you are expecting. Then we have sprint retrospective, a meeting after the sprint review for the team to reflect on the sprint and identify areas for improvement. So in this meeting we discuss what went well, what we could have done better, is there any blocker or something, or sometimes we give recognitions also to the people, like the people who are doing amazing job, we recognize them so that their morale will boost up, right? All these things come in the sprint retrospective. Now let's understand the benefits of Scrum. Flexibility, adaptable to change and can respond quickly to new requirements that we have seen. Collaboration, it enhances teamwork and communication among team members and stakeholders. Continuous improvement, and by the way I just used the Scrum terminology, this formatting was not correct, I just made it from white to yellow, so I just used the Scrum here. Okay, continuous improvement encourages regular reflection and adaptation, leading to better processes and product over time. Customer focus, frequent feedback loops ensure that the product aligns with customer needs and expectations. So Scrum is widely used across various industries beyond software development, including marketing, education, and product management, due to its effectiveness in promoting collaboration and delivering value efficiently. Okay, next Agile framework is Kanban. Let's see what is Kanban. Kanban is a visual workflow management method used to optimize and manage work processes. It emphasizes continuous delivery, efficient and flexibility in various fields, including software development, manufacturing and service industry. So first let's understand what is Kanban board, because that way we will be able to understand what is this whole thing. A Kanban board is a visual management tool used to organize and track work in progress. It typically consists of columns that represent different stages of workflow. So the columns would be, for example, to do tasks which are not yet started. In progress, tasks means started and the team is working on those tasks. Done means the tasks are completed. and there can be other stages also. So for example, in review, if the task is development is complete and it's for ready for an SME for to review, etc., right? So we can have additional columns as well. Tasks or work items are represented by cards which are moved across the board as they progress through the stages. The Kanban method helps team visualize their work, limit work in progress, and improve flow. It originated in manufacturing but has been widely adopted in software development and other fields for its flexibility and effectiveness in managing tasks and improving efficiency. So let's see first how to set up a Kanban board. So to create a board, either we can use a physical board, right, or we can have some digital platforms also available. So for example, we have few digital platforms like Trello, Jira, etc., right? Or we can just simply use a whiteboard and we can just put some sticky notes also, right? So the very first thing is define your workflow, identify the stages of your process, and like I said, to do tasks, in progress tasks, in review tasks, and done tasks, right? So we can have those columns. I mean, these are the different stages or different stages we will encounter within our process, and then we can of course customize these stages. Then we need to of course create the task cards. For each task, create a card that it should include a brief description, only one liner, sometimes just a headline title, any relevant details like what is the due date, who is the assignee, or any link if it is a digital dashboard, and then priority label if applicable. Mostly it is applicable that what is the priority of that task. And then we need to set work in progress limits, decides on limit for how many tasks can be in the certain stages at one time. So for example, given a time, a maximum of 3 tasks it can be in progress state, right? Because we also need to make sure that there is a progress, right, in the work item. There is a progress. And then of course we need to use the board regularly. Make it a habit to update the board regularly. We sometimes have the stand-up calls also, like for example 15 to 20 minutes call where all the team members will join that call, will explain, okay, this is the task which is in to do yesterday, which was in to do yesterday, and now I started working on it, so that's why it moved to in progress state, something like that. And move tasks as their status changes, and hold regular meetings like daily stand-up to discuss progress and challenges. Reflect and adapt, periodically review your workflow and make adjustments as necessary. This might involve changing stages, adjusting work in progress limits, or redefining how tasks are managed. And this is just a sample how it will look if you are using a digital platform, or even if you are using sticky notes on the whiteboard. That is fine. So what we just learned that we can have different columns. So for example, to do column, in progress column, review column, done column. There can be some customized columns as well. And consider these cards are nothing but the tasks which team is going to work on. So for example, somebody is working on some UX design, another person is working on the backend functionality work, right? These multiple tasks, right? So on this board, there will be the whole team will have those cards, and then they will change the so for example, yesterday this task D was in to do state, and the person has worked on it, so now it should be in progress state. So while in the stand-up call, or maybe previous to that, the person will change the status. If it is a physical board, the sticky note, he will just pick this sticky note from here, will paste it here, right? And if it is a digital dashboard, then we have workflows available. We just change the status from to do to in progress, or any of the applicable. So this is how we manage the Kanban board using the various type of cards. Let's see few tips for effectiveness of Kanban. First thing is keep it visual, because visual means it will be interactive. Use colors or tags for priority labels. Tags are nothing but if we are using the digital dashboard, then those platforms provide tags feature. So for example, something should be available for some review, right? So we can just tag that card with the review tag, right? So we can create tags also if we are using any digital platform. For example, in Trello, etc., we have use colors or tags for priority levels, types of tasks or team members. Stay flexible, adapt the board as your team's needs evolve, right? And involve the team members. Get input from all team members to ensure the board meets everyone's needs. Now, since we know about Kanban, let's see the key principles of Kanban. First thing is, of course, visualize the workflow. Use a Kanban board, either physical or digital, to visualize the workflow. Each task is represented as a card, and the board is divided into columns that represent different stages of the process. To do in progress set done. Limit work in progress. Set limits on the number of tasks that can be in progress or at any time. One time, this helps to reduce the bottlenecks, maintain focus, and improve overall flow. Focus on flow. Monitor the flow of tasks through the system. The goal is to ensure smooth transition between stages, minimizing delays and improving efficiency. On continuous improvement, encourage a culture of continuous improvement, often referred to as Kaizen. Regularly assess the process, identify areas for enhancement, and implement changes to optimize performance. Let's see a few benefits of Kanban. Sometimes people call it as Kanban. So either way. Okay. Flexibility. Easily adapt to changing priorities and workload. Provides a clear visual representation of work status, making it easy for teams to see what is being worked on and what is next. Efficiency. Helps identify bottlenecks and inefficiencies, leading to improved workflow and productivity. Focus on value. Emphasizes delivering value to customers through continuous improvement and responsiveness to needs. So in summary, Kanban or Kanban is widely applicable across various domains such as software development, project management, customer support, personal task management as well, right? It is particularly effective in environments where work is unpredictable and priorities can change frequently. Kanban is a powerful method for visualizing work, managing flow, and fostering a culture of continuous improvement, making it a popular choice for teams aiming to enhance productivity and collaboration. Now we have learned Scrum and Kanban. Let's see what is the difference. So this tabular format I just put in so that we can see all the differences or align what is changed between Kanban and Scrum. So framework type, it's continuous flow and it's iterative and increment flow, right? We have visualization here, and Scrum is basically organizing the work into fixed length sprints. So like 1, 2, 4 is sprints, right? In Kanban, we do not have any defined roles, whereas in Scrum we have defined roles. We have product owner, Scrum master, development team, etc. And work in progress limits. Yes, of course we have the limit on work in progress, whereas there is no restriction of work in progress items limits. There is no such restriction. Planning perspective, continuous planning is needed in this Kanban, whereas in Scrum, sprint planning at the start of each sprint, that is needed. Change management, changes can be made at any time, right? Anytime. So usually that's why Kanban is also used for, so for example, if there is any production issue, there is a production issue L1, L2, L3 support fixing team. So that is also one of the use case where we should use, or we can use Kanban, because anytime if there is a production issue coming, that ticket should be taken by the team to work upon. So that is not a good use case for Scrum team, because Scrum work is already decided before the sprint starts, right? In Scrum, changes are generally not allowed during a sprint. So yes, time frame, no fixed time frame. Tasks are completed as capacity allows, and in Scrum we have fixed time frame, which is a sprint, typically 1 to 4 weeks. Meetings, minimal required meetings, ad hoc discussions, whereas in Scrum, regular ceremonies, sprint planning, daily stand-up, sprint reviews, sprint retrospective, all those ceremonies happen. Focus, continuous delivery and flow optimization is the focus of Kanban. Whereas for Scrum, delivering a potentially shippable product, and we call it as PSP, increment at the end of each sprint. And PSP is nothing but that product which we are building in 1 to 4 weeks of time. That itself is a component which can work individually, right? Adaptability, highly adaptable, easy to implement changes, and Scrum is more structured. Changes require more planning and can disrupt sprints if there is anything which is coming in between. Now let's see, since we have learned Agile, let's see what are the advantages of Agile framework. Rapid delivery, frequent releases provide users with early access to features and improvements, right? 1 to 4 week of sprint, for example, if we talk about Scrum, right? Within a few weeks we are releasing those new features or fixes to the production environment, so it's a rapid delivery. Increased collaboration, continuous interaction with stakeholders leads to better alignment with user needs. So within Scrum, so for example, we do those show and tell session, we get the feedback before we put that feature on the production environment. We show it to client, see this is what we have built, is it working fine? We take the feedback and then sometimes we improve those things, right? So the collaboration is increasing with the stakeholders. Higher quality, regular testing and feedback help identify issues early, resulting in improved product quality. Yeah, this is self-explanatory. Let's see a few disadvantages of Agile framework. First one is less predictability. Project timelines and budgets can be harder to estimate due to the iterative nature of Agile. Right, so someone says like, can you give me estimate of this project right away? So it's not predictable. Requires a discipline. Teams must be well organized and committed to regular communication and collaboration. So I think people are actually not needed in Agile framework, because I mean the lesser duration, consider we just have 1 week of a sprint. So within 1 week, we need to make sure we push this change to production, right? If people are just sitting idle on the item, of course, that won't be a successful release. So we need discipline. Risk of scope creep. Frequent changes and additions can lead to project scope expanding beyond original intentions. So here actually the main role of Scrum Master comes into picture, where this person should be should be a little bit stubborn as well, that we cannot introduce any item during the sprint, for example, right? So concluding, the Agile model is well suited for projects in dynamic environments where requirements may evolve. It fosters collaboration, adaptability and continuous improvement, making it a popular choice in software development today. Yeah, this is one of the, I mean, most of the job descriptions would have this as one of the JD. The person should know Agile. The next one is DevOps model. Let's see what it is. The DevOps model is an approach to software development that emphasizes collaboration between development team or dev team and operations team, ops team. And that's why it's DevOps. It aims to shorten the software development lifecycle while ensuring high quality and continuous delivery of software. So these people, right, the development team, operations team, I mean the people who are going to deploy that code to production environment, those are the operations team members, by the way. So they are working together in a collaborative manner. Developers are fixing it, developers are developing it, pushing it to the environment, and then operation team, they are just deploying it. Let's see key components of this model. The very first thing is, of course, collaboration. DevOps fosters a culture of collaboration between developers, operations and other stakeholders, breaking down silos and encouraging open communication. You cannot keep hot potatoes in your hand. You have something to speak about, just speak. You need to inform team members that, okay, I'm blocked because of this issue, or maybe another party is not responding, right? There is another integration you need to do. You are not getting response from the DBA, right? So the collaboration is first thing. Automation of processes such as testing, deployment and infrastructure management is a core principle. This helps reduce manual error and speed up delivery. I mean, nowadays this automation, right? Whether it's testing automation or deployment automation is a must for anything. Consider a scenario where we are working in this DevOps activity, right? And we have a huge application to be tested, and every time we are releasing a new feature, and then we need to do this testing again. Manual testing. And then it will take a lots of effort. And of course, with manual effort, we might miss something. So automation is needed. Continuous integration. Developers frequently integrate their code changes into a shared repository. Automated builds and tests are run to identify issues early. Now consider a scenario. We have different teams, a common repository, and different teams are working for different features. And if we do not have automation build, whether it's automation build, automated build, or automated test, what will happen? Multiple teams are pushing their code, and end of the day we are not sure if the code is working fine or not, if the build is successful or not, and then finally the test cases are breaking. So for this model, for DevOps model, we surely need automated builds. As soon as people check in their code to the repository, automatically the build will start. We'll see if there is any compilation level error, etc. And then automated test, those test cases should also be executed. Then only this model will work. Continuous delivery. The goal is to ensure that code changes can be automatically deployed to production at any time. This involves rigorous testing and validation processes. Monitoring and feedback. Continuous monitoring of applications and infrastructure provides real-time insights into performance and user experience. Feedback loops help teams quickly identify and resolve issues. Infrastructure as a code. IAC. This practice involves managing infrastructure through code and automation, allowing for consistent and repeatable environments. Now let's see a few benefits of DevOps model. So first benefit is of course faster time to market. By streamlining processes and enhancing collaboration, teams can deliver new features and updates more quickly. Improved quality. Continuous testing and monitoring help catch bugs and performance issues early, leading to higher quality releases. Greater efficiency. Automation reduces manual tasks, allowing teams to focus on more strategic initiatives. So for example, there can be some improvement on your website, so we are receiving some feedback, we are putting some innovations around the solution. We can put more automation around something else, maybe some approval process, maybe the content which we are putting on our website needs some approval, some business approval, some legal approval. How can we automate that process, right? So think of something else which will add some value to our portal. So team can think of that. Enhanced customer satisfaction. Faster delivery of features and quicker responses to issues lead to improved user experiences. So these are the benefits. Let's conclude it. The DevOps model represents a cultural shift in how software is developed and delivered. By integrating development and operations, organizations can achieve greater agility, improve collaboration, and respond more effectively to market demands. Now let's understand another agile model, which is rapid application development model. Rapid application development, or RAD, is a software development methodology that emphasizes quick development and iteration of prototypes over a rigorous planning and testing. This approach is designed to provide fast delivery of high quality software by using a combination of pre-built components and user feedback throughout the development process. Let's see the key features of RAD model. So user involvement. RAD relies heavily on user feedback and active participation throughout the development cycle, ensuring that the final product meets user needs. So user involvement is needed. Then prototyping. Instead of waiting for the complete system to be built, RAD encourages creating prototypes or partial implementations that can be tested and refined based on user input. And actually that is a crux of agile methodology. Create small product. So for example, in terms of Scrum, we used to call it as PSP, right? The shippable product, right? And then validate them instead of like building the whole thing as once, right? Create small deliverables and then validate and then put it on production. So here also the same concept is there, but we are calling it as prototyping. The next one is iterative development. So that is also one of the feature of agile model, agile methodologies, iterative development. The development process is iterative, allowing for continuous refinement and enhancements. Each iteration can lead to a more polished product. RAD or RAD aims to reduce development time significantly, allowing organizations to deliver applications faster compared to traditional methodologies. And RAD often employs various tools and techniques such as visual programming to streamline the development process. Let's see the phases of RAD model. Okay, so these are the phases: requirements planning. Initial requirements are gathered from users and stakeholders to outline what the application needs to achieve. That is like requirement gathering and planning. User design. Users collaborate with the developers to create prototypes. This phase focuses on designing user interfaces and experiences. UX, sometimes we call them as UX design. Construction. Developers create the actual application, often using high-level programming tools and techniques. Prototypes are continuously refined based on user feedback. Cutover. The final application is deployed. This phase may include final testing, user training, and data conversion. Now let's see the advantages of RAD model. Speed. RAD allows for rapid development, which we have seen, which is ideal for projects with tight deadlines or changing requirements. Flexibility. The iterative nature of RAD enables developers to adapt to changes and feedback quickly. User-centric. By involving user throughout the development process, RAD helps ensure that the end product meets user expectations. Reduced risk. Continuous testing and prototyping help identify and address potential issues early in the development process. Now let's see what are the disadvantages of this. Limited scalability. RAD may not be suitable for very large projects due to its reliance on user involvement and rapid iteration. It requires strong collaboration. Effective communication and collaboration among users and developers are crucial for RAD to succeed. Yeah, it's not like team is just sitting on one task and thinking, okay, today I am not in mood, maybe I will work tomorrow. Okay, potential for incomplete requirements. Rapid iterations might lead to overlooking some requirements, especially if user feedback is not adequately captured. That is also one of the important thing here. Okay, this model, that is rapid application development, is a valuable methodology for projects that require quick turnaround and high user involvement. By focusing on prototyping and iterative feedback, RAD helps deliver functional applications that align closely with user needs, making it a popular choice in dynamic environments. So far we have covered traditional models, then we covered agile models. Now we will learn the modern and hybrid models. And these models we are going to cover: spiral model, feature driven development or FDD model, lean software development model, pod model. So the first one is spiral model. The spiral model is a software development process that combines iterative development with the systematic aspect of the waterfall model. It is particularly useful for large, complex and high-risk projects. The model emphasizes risk assessment and mitigation throughout the development lifecycle. So it's a traditional, so there was a traditional approach, there is a agile, and then now this is like taking some features of waterfall model, the traditional one, and some features of agile one, right? Basically good features, not bad features. So let's see the features of spiral model. First one is iterative process. The spiral model allows for multiple iterations or spirals. So in Scrum we used to call it sprint, here we will call it as spirals of development, enabling teams to refine and enhance the product over time. Risk management, each phase includes a thorough risk assessment, allowing teams to identify and address potential issues early in the development process. Customer feedback, regular customer involvement ensures that the evolving product meets user needs and expectations. Flexible and adaptive, the model accommodates changes in requirements even late in the development process, making it suitable for dynamic projects. Now let's see the phases of spiral model. Planning, identify objectives, alternatives and constraints, define the project scope and gather requirements. That is planning phase. Risk analysis, evaluate risk associated with the project. This may involve creating prototypes or conducting feasibility studies to assess technical and operational risks. Engineering, develop the software incrementally, implementing features based on the prioritized requirements. This phase includes design, coding or testing. So to be true, if you see, right, the naming conventions have changed in these models. So for example, instead of we are saying different phases of design, coding and testing, we have already seen in waterfall model, right? Now we are calling this as an engineering phase, which is a combination of those phases, right? So some terminologies have changed, and what these models are trying, they are trying to get the best of features available in existing models and trying to improve them. So that is the whole thing which is happening in these models. And why it is crucial to know all these terminologies, because when we are working for a team and the project use any of a specific model and we do not know the terminology, it will become more confusing. What is the meaning of engineering, right? Then evaluation, review the project progress and gather feedback from stakeholders. This helps determine whether to proceed to the next spiral, make adjustments or pivot the project direction. And repeat the process, repeat for multiple iterations, refining the product and addressing any new risk or requirements identified during evaluation. So I mean, since it's an iterative model, right, so of course there will be a repetition. Let's see the advantages of a spiral model. So the first one is effective risk management. Continuous risk assessment helps prevent major issues before they arise. So risk management is like a continuous phase, that's why it's one of the advantage. Customer satisfaction, regular feedback loops with clients ensure that the product aligns with their needs and expectations. Flexibility, the model's iterative nature allows for adjustments based on evolving requirements. Let's see the disadvantages of this model. Complexity, the model can be more complex to manage compared to linear models, requiring careful planning and coordination. And to be true, even if it is a linear model, which is not advisable at all, so for example waterfall model, there also we need planning. There also it will become complex if the planning is not done properly, right? So this is applicable for any of the model, the complexity, right? Cost, yes, this can be a factor due to its iterative nature and the need for ongoing risk assessments. It may be more expensive than other models. So let's conclude the spiral model. The spiral model is particularly suited for projects where requirements are uncertain or subject to change. Its focus on risk management and customer involvement makes it an effective approach for delivering high quality software solutions in complex environments. Now this one is feature driven development model or FDD model. Feature driven development or FDD is an iterative and incremental software development methodology that emphasizes the design and building of features. It is particularly suited for larger scale projects and focuses on delivering tangible working software in short time frames. So again, to notice, this is also iterative. Okay, so means smaller increments will go. smaller functionalities will be built and will be released. Let's see the key characteristics of FDD. Feature centric approach. The core of FDD is its focus on features, which are small client valued functions that can be designed, built and tested independently. Each feature typically represents a specific piece of functionality. So for example, login functionality, registration functionality, right, any newsletter functionality. So these are the features which are small and of course that can be designed, built and tested independently. Model driven. FDD begins with building a model of the system which is then used to guide development. This model helps ensure that all stakeholders have a shared understanding of the system. Iterative and incremental. Development occurs in short iterations, usually 2 weeks, where a set of features is designed and implemented. So this allows teams to respond to changes and continuously improve the software. So kind of Scrum. Regular builds. FDD promotes frequent builds, ensuring that the software is always in a working state. This helps identify issues early and maintains a high quality of code. So kind of Scrum only. All features are like, for example, increment delivery, iterative in nature, regular builds. Kind of DevOps model is also introduced here, right? Because of course the dev team and ops team, they need to work close. So like I said, in all these models, right, what we are doing is we are taking some good features of one model, good features of another model, renaming it as another model. That is in a nutshell we have done. Let's see the phases of feature driven development model. Okay, develop an overall model. The team collaborates to create a high level model of the system that outlines its structure and functionality. Build a feature list. A comprehensive list of features is created based on client requirements and the overall model. Each feature is typically a small specific piece of functionality. Like I said, maybe a login functionality or registration functionality. Plan by feature. The features are prioritized and planned for implementation in a series of iterations. So for example, my web application is having login feature, that is login feature, sign up feature, newsletter feature, right? So priority wise, which one will come first? First sign up will happen, so registration will become the first feature, then login should happen, so login will become the second feature, and so on. Design by feature. For each feature, detailed design work is performed, ensuring that it meets the requirements and fits within the overall architecture. Build by feature. The development team implements the feature, conducts testing and integrates it into the existing system. Let's see the advantages of FDD. So first advantage is customer centric. By focusing on delivering features that provide value to clients, FDD aligns development closely with user needs. Predictability. The structured approach with defined phases helps in better planning and predictability of timelines. Enhanced quality. Regular builds and testing throughout the development process lead to higher quality software. Team collaboration. FDD promotes collaboration among team members, fostering a shared understanding of the project. So these are the advantages of FDD model. So let's see the disadvantages also. Okay, the first one, requires experienced team. And to be true, this is not a disadvantage. We always need experienced people, innovative people in our team, right? Okay, FDD works best with experienced team that can handle the complexity of feature-based development, right? So we need experienced team. So for example, consider there is a development of any of the project and we are using waterfall model. This project is of 6 months. People are working on this project. It's okay. Sometime if someone is not feeling good, maybe today he can work tomorrow, right? But whereas such type of model where we need active people, experienced people all the time, because the duration of the sprint, or whether it's a sprint or any of the model we are using just 1 or 2 weeks, we need to complete the whole functionality. We need experienced people, right? We need experienced team. Okay, less flexibility for changes. While FDD allows for changes, the structured nature can make it less adaptable compared to more agile methodologies. Initial overhead. The upfront effort to create a comprehensive model and feature list can be time consuming. So, in conclusion, FDD or feature driven development is an effective methodology for managing complex software projects, particularly where features play a critical role in delivering value to users. Its structured approach, combined with an emphasis on iterative development and regular feedback, helps teams deliver high quality software that meets client expectations. This model is lean software development model. Lean software development is an agile methodology derived from lean manufacturing principles and practices, aiming to optimize efficiency and minimize waste in the software development process. It emphasizes delivering maximum value to customers while using the least amount of resource. Let's see the key principles of lean software development. Eliminate waste. Focus on identifying and removing anything that does not add value to the customer, such as unnecessary features, documentation, and processes. Build quality. Quality should be integrated into development process from the start. This involves practices like continuous testing and validation to ensure that defects are caught early. Create knowledge. Emphasizes the importance of learning and adapting. Teams should continuously seek to improve their processes and products through experiment and feedback. Yeah, and defer commitment. Decisions should be made as late as possible, allowing teams to gather more information and reduce uncertainty before committing to a course of action. Deliver fast. Focus on delivering small incremental releases to provide value to customers quickly. This allows for faster feedback and the ability to adjust based on customer input. That's why it is using the agile methodology. Respect people. Lean development recognizes that people are the most important asset. It encourages teamwork, collaboration, and respect for all team members. I really like this one, right? People matter first, the health matter first. All these models are, I think, the second aspect. Anyways, optimize the whole instead of optimizing individual components. The entire value stream should be considered. This means looking at how different parts of the process interact and ensuring that the whole system is efficient. Let's see what are the lean practices. Value stream mapping, a technique to visualize the flow of information and materials required to bring a product to the customer, helping identify waste. Okay. Second is continuous improvement or Kaizen, culture of ongoing improvement where teams regularly evaluate their processes and make incremental changes for better efficiency. Pull systems, instead of pushing work through the system, lean practices advocate for a pull system where work is pulled based on demand, reducing overproduction. Rapid prototyping, quickly creating mock-ups or prototypes to gather feedback and iterate on design, minimizing the risk of developing unwanted features. Let's see the benefits of lean software development. So first one is increased efficiency. By eliminating waste, teams can focus on what truly matters, leading to faster delivery times. Higher quality, building quality into the process reduces defects and improve overall product quality. Greater flexibility, lean principles allow teams to adapt quickly to change requirements and customer needs. And enhanced collaboration, emphasizing teamwork and respect, foster a positive work environment and encourages knowledge sharing. Now let's see the challenges of lean software development. First one is cultural shift. Transitioning to lean practices may require a significant cultural change, within an organization, which can be difficult to achieve. Initial investment, time and resources may be needed upfront to train teams and implement lean practices effectively. And then balancing speed and quality while delivering quickly is a priority. Maintaining quality standards, of course, it's essential, and finding the right balance can be challenging. And concluding, lean software development provides a framework for improving efficiency and delivering value in software projects. By focusing on waste reduction, quality, and continuous improvement, teams can enhance their processes and better meet customer needs. It's a flexible methodology that can be adapted to various types of projects, making it a valuable approach in today's fast-paced development environments. So this is pod model. Let's see what it provides. Pod model is the pod model project-oriented development. Is a software development approach that emphasizes organizing teams around specific projects or products rather than functional areas. Let's see the key features of this model. Team structure. Teams are composed of cross-functional members, including developers, designers, testers, project managers, who work collaboratively on a specific project. So for example, we have a bigger enterprise, and then we are working for different projects for that enterprise. So for different projects, we will have different teams, different pods. Each pod will have a developer, a designer, tester, project manager, business analyst, okay, and they will work together collaboratively on that specific project. Second is project focus. Each team is dedicated to a particular project, allowing them to concentrate on its specific requirements, goals, and timelines. Flexibility and agility. The pod model encourages adaptive planning and responsiveness to change, making it suitable for dynamic project environments. Ownership. Team members take ownership of their project, leading to increased accountability and motivation. Faster delivery. By having a dedicated team, projects can progress more rapidly as team members can make decisions quickly without waiting for approval from multiple departments. So for example, there are multiple departments, right? And this team is formed for one department. Since there is no impact of this department to another department, this team can take decision among themselves and then can provide faster delivery. Enhanced communication. Close collaboration among team members facilitates better communication and reduces misunderstandings, resulting in higher quality outcomes. And sometimes in this model, even from the client side, there will be a specific SPOC, specific project manager from the client side. The pod team is going to interact with that manager or the architect. They are going to work together and they are just focused on that particular department to which they are working on. So that's why the delivery will be more faster. Now let's see the benefits of this model. First one is, of course, improved collaboration. Cross-functional teams foster a collaborative environment. They will work together. Within a team, we will have all those cross-functional people, be it developer, front-end developer, back-end developer, content authors, etc. And they are working together to complete that project. And sometimes, within a model, we have combination of different models. So for example, we have pod, we are following pod method, but we are also using features of Scrum or features of Kanban. So that is also possible. We can always tailor a specific model. Faster time to market. Projects can be completed more quickly due to focused efforts. Higher quality. Direct involvement of all necessary skills leads to better quality assurance. Greater adaptability. Teams can quickly pivot in responses to project needs or client feedbacks, right? And then of course the development team, they fix it, they work with the DevOps team, and then they push the changes to the higher environment. So what I am saying that though is pod model, but we are also maybe using the Scrum features, but we are also using the features of Kanban model, and we are also using the features of DevOps model. So it is always tailored. It is not fixed to one model, SDLC model. We can always bring the best features of various models available, and then can create our own tailored model. Let's see the use case of pod model. Pod model is particularly beneficial in industries where projects are varied and need tailored solutions, such as software development, marketing campaigns, product launches. It allows organizations to leverage specialized teams for each project while maintaining flexibility and speed in delivery. Overall, the pod model helps organizations effectively manage complex projects by fostering teamwork, accountability, and adaptability. Okay, let's see the summary of all traditional models. So we covered waterfall model, V model, and incremental model, right? So waterfall model is a linear approach where each phase must be completed before the next begins, right? That is waterfall model. V model, an extension to the waterfall model, emphasizing verification and validation, that we have covered. So each phase of the development is having corresponding testing phase. So it is giving more stress on the testing. Incremental model develops a system in increments, allowing parts to be deployed as they are completed. So kind of agile they have brought in here. Okay, advantages of waterfall model: it's simple to understand, clear documentation. V model ensures thorough testing, clear project timelines, milestones, right? Thorough testing is more stress on testing for sure. And incremental model allows partial implementation. Feedback can be incorporated because it is delivering in increments. Waterfall model disadvantages are inflexible to changes. Late testing can lead to discovering flaws too late. All right, we cannot go back to the previous phase and do something. Okay, V model, inflexible changes can be costly late in the process, and the incremental model, integrations can be challenging. Incomplete systems may confuse stakeholders. Let's see the summary of agile models. So we covered agile model, DevOps model, and RAD model. Agile model is an iterative approach focusing on collaboration, customer feedback, and rapid releases. So it's iterative in nature, right? We covered Scrum and Kanban. We can create sprints, etc. Right? DevOps model combines software development and IT operations to shorten the development lifecycle, and RAD model focuses on rapid prototyping, small features, and quick feedback from end users. Agile model advantages: it's highly adaptive, encourages customer involvement, frequent delivery. Advantages for DevOps model: faster delivery, improved collaboration between teams, increased deployment frequency. And RAD model: faster development, encourages user feedback. Disadvantages of these models are: for agile model, it requires constant collaboration. That is not actually a disadvantage, but of course few people might think it's a disadvantage. Okay, can be challenging to manage scope and timelines. For DevOps model, it requires cultural change and collaboration between previously siloed teams. For RAD model, may compromise quality if time is too short, requires active user involvement. Now let's see the summary of modern and hybrid models. So we covered these models: spiral model, feature driven model, feature driven development or FDD model, lean software development model, or pod model. Spiral model combines iterative development with systematic aspects of the waterfall model, emphasizing risk. Feature driven development model, an incremental model driven approach focusing on delivering tangible features. Lean software development model emphasizes efficiency and waste reduction, delivering value by streamlining processes. And pod model organizes team around specific projects or products promoting cross-functional collaboration. Advantages of spiral models are it focuses on risk management, allows for refinement of project details. Advantages for FDD models are it clear focus on features, promotes regular delivery and customer satisfaction. For lean software development, the advantages reduce waste, encourages continuous improvement. And for pod model, advantages are it improves collaboration, faster delivery, adaptable to project needs. Disadvantages for spiral model, it can be complex to manage, requires expertise in risk management. For FDD model, the disadvantages could be it requires a well-defined scope, may not suit projects with rapidly changing needs. For lean software development, disadvantage could be it can overlook essential features if too much focus is placed on efficiency. And for pod model, it can lead to resource duplication, may create silos if not managed properly.